Okay, so in this video, we're going to talk about line and best fit some more, and we're going to be going into now practicing interpreting line y-intercept stuff, but we're going to add in interpreting a slope and the equation of a line. So first off, I'm going to do an example here of an entire problem here, and then we're going to kind of walk through another one, and then I'll have you try one by the end of the video. Okay, so first off, though, I think we could all describe what this association is. So describe this association for me. Okay, so for strength, this one is strong. So I'm going to write strong for this one. Our direction, okay, our direction is positive. Our form is pretty linear. Okay, this one would be linear. And any outliers, yes, we have one outlier way at the bottom, okay? We have one way at the bottom. That's way outside of what the rest of the data is. Now, interpreting the slope. So what does the slope represent in this situation? Well, they give us the equation here up at the top right, okay? The equation is y equals 1.5x. So our slope here is the 1.5. It's always the number in front of the x because it's like y equals mx plus b. We're looking at the m, okay? So that's our slope. Now, we got to remember so slope is change in y over change in x, which means we're looking at how does the y variable change over how does the x variable change. So for this, it would be like I'm going to write it off here on the side, 1.5 over 1, which the units for our change in y is number of typos found, okay? So it would be 1.5 typos found, okay? Or 1.5 typos, okay? Because that's the label for the y, divided by 1 of our x, which is number of chapters. So we'd have 1.5 typos, and that would be over 1 chapter. Okay? Now, another word for division is per. So when we actually write this out, we're going to say 1.5 typos per 1 chapter. And that is the interpretation of the slope. So it's just taking your slope and adding the labels to each change in y and change in x. But we want per 1 of the x. We always want just 1 of the change in x. We never want to say 2 of the change in x. I want to say 1.5 typos per 2 chapters. I want to make sure I say per 1 of whatever our x variable is. But that's how we can go about interpreting the slope, is that change in y over change in x, putting those labels with them, and then it's per 1 of the x, okay? So interpretation of the y-intercept. So this is like what we talked about in class the last time. Find the y-intercept. In this case, our y-intercept here from our equation is a plus 0. So that means, what does our y-intercept for this one mean? So we have 0 typos after or in 0 chapters. And that would be our interpretation of the y-intercept here. I find the y-intercept, that tells me my y value, but it's in 0 of whatever the x variable is. Okay, we always have 0 of the x variable for the y-intercept. Now, use the equation to predict the number of typos in an 18 chapter textbook. Well, this will use our equation. Number of chapters is x, so I'm going to put 18 in for x. So I'm going to go y equals 1.5 times 18. And if you want, you could say that plus 0, but you don't have to. Okay, so solving this, I get y equals 27 typos. And then don't forget your label on that, okay? Just solving that using a calculator, I get 27 typos. Now, the last question is describe the outlier, okay? So when we describe outliers, we're just going to talk about how is it different, okay? Or what makes it unique. Well, and in this one, you can see here, it's down in the bottom right, which means we have a high number of x, our x variable, which is we have a high number of chapters. So I'm going to say a high number of chapters. But in this case, we have a low number of typos. So I'm just going to say, but a low number of typos. Okay, that's what makes this one unique, because usually the more chapters we have, there's more typos. But this one, instead of having a high number of typos as well, we have that low number of typos. And that's how we would describe this outlier to make it more unique. I'm not going to worry about the numbers because numbers we're not always going to be able to tell. I would just say, in this case, a high number of chapters, but a low number of typos. All right, so let's look at another one here. Okay, so we have the equation is y equals 0.136x plus 74. We have the x-axis is distance in miles. We have the y-axis is cost of a plane ticket in dollars. Okay, so I want you to go ahead and describe the association here using strength, direction, form, and outliers. All right, so this one here, I would say this one is moderate, in my opinion. Okay, because we have a little variance here. It's not in a very linear form like the last problem. We have a little jump around. Okay, our direction is positive. Our form is still this one will be linear. If I can type linear. And outliers, yes, we have one outlier again. We have one outlier. Okay. So, interpretation of slope. I want you to try this one now, the interpretation of slope. All right, so this one, remember our slope here is change in y over change in x, which is the 0.136. Okay, so that's our slope. So I'm going to write it. I'm going to do it again as a fraction over here on the left-hand side. I have 0.136 over 1. The change in y is the 0.136, which is our cost of plane ticket, which is in dollars. So I'm just going to say $0.136. Okay. And then it's going to be over 1 of the distance in miles. So I'm going to say over 1 mile. Now, when we write this out, remember division is per. So I'm going to say $0.136 per 1 mile. Remember, it's per 1 of the x. So per 1 mile. The interpretation of the y-intercept. Go ahead and try this one. All right, so for this one, our y-intercept is 74. So we have $74, okay? But when does this occur at? Well, I would say when at 0, because what's our 0 at? That's going to be our x variable, which is at 0 miles. So to go 0 miles, you would still pay $74. It's just like getting on the plane and then just sitting on there. So you can kind of think of that. Use your equation to predict the cost of a plane ticket if traveling 2,500 miles. Show your work, label your answer. Try this one out now for me. All right, so we're going to put 2,500 in for x. So I'm going to go y equals 0.136 times 2,500 plus 74. Okay, we're going to type all that in. Okay, and we're going to get an answer of, let me type it in here, 0.136 times 25000 plus 74. We get a total of 414, and don't forget your label dollars. Okay, $414. Last question. Point B is an outlier in this data set. Describe point B in this context of this situation. Okay, so let's give this one a shot now. All right, so this one here, we have, you can see it's not very far on the x. So I would say a low number of miles, since that's my variable for the x, low number of miles, but a high cost in dollars. Okay, a high cost in dollars. It's the unique thing about this one, it doesn't have very many miles, but it's a very high cost. Okay, it's instead of following the trend of it gradually getting bigger the more miles, we have that low miles, but it costs an extremely high amount. Okay, it reminds me of like whenever I fly, sometimes I don't fly very far, but it's a high dollar amount. Like one time I went to Nashville, it wasn't a very far flight, but it was a high amount of money to fly there than it normally was. So I had that anomaly there because I need to get there for something very important. Okay, so that was a unique case too for me because I had the outlier of the plane ticket cost. All right, so let's try one more here. Okay, I got an equation. I got the same question set here. All right, so go ahead and answer go ahead and work through the first question for me. Describe the association. All right, so this association, the strength, I would say is moderate again. Okay, we have some variance on our line. The direction is the direction is negative this time. We're decreasing here. Our form is linear. And our outliers, yes, we have 1. Okay. Now, I want you to go ahead and do the interpretation of the slope. All right, so the interpretation of slope, I'm going to do it right below it here. So I have more room. I'm going to do the same thing. I'm going to put it over 0. I'm going to put them as a fraction, changing y over changing x. So I have negative 0.0062 over 1, which remember, it's change in y, so our variable for change in y is degrees Celsius. Okay, over 1 of our x, which is, in this case, m, which is meters. So when I write this out, I'm going to say negative 0.0062 or negative 0.062 degrees Celsius per 1 meter. Remember, it's per 1 of the x. Interpretation of the y-intercept. Well, find the y-intercept here up from the equation. Okay, and use this one now to interpret it. All right, so for this one, what does the y-intercept mean? Well, it means 23.34 degrees Celsius when at 0 meters in elevation. Or I could say when at an elevation of 0 meters. Something on the lines of that. Okay. Now I use this equation to predict the temperature at the elevation of 4,000 meters. Let's try this one out. All right, so this one you're going to put 4,000 in for x. You're going to do y equals 0 or negative 0.0062 times 4,000 plus 23.34. Type this into a calculator. So I'm going to type it in here, negative 0.0062 times 4,000 plus 23.34. And we get our elevation is going to be negative 1.46 meters. Okay, negative 1.46 meters. All right, now you can't. Your elevation, remember the elevation is set at the equator, if I remember correctly, it's a 0. Okay, or there's a spot where it's set at 0. It might not be the equator. I can't remember exactly where it's at. But that tells you your set point. You can go below the 0 elevation. Okay. All right, last one, describe the outlier here. So describe our outlier of point A. Okay, so this one, we have a high elevation. So I would describe it as a high elevation and also a high temperature. Okay, that's how this one we would describe this one. It also has a high temp. Okay, because it's very far over on the x and it's also really high on the y. So it has a high elevation and it has a high temperature. Okay, if you have any questions, please let us know as we'll continue this in class.